a 2 kilogram aluminum block and 6 kilogram copper block are connected by a light string over a frictionless pulley. The two blocks are allowed to move on a fixed steel block wedge of angle theta, which is 30 degrees, as shown in figure P4.67. Making use of table 4.2, determine A, the acceleration of the two blocks, and B, the tension of two strings. Okay, so we have this copper mass here is 6 kilogram and the aluminum block is 2 kilogram. So by our intuition, we know that it will move there, right? So let's assume that is the direction of movement. And we need to find out the acceleration of the system and then the tension of the string. Okay, let's start with this aluminum block and let's draw what forces that work on the aluminum block. So here, let's draw all the forces. The first one obviously is the weight. I will name this as W1 for weight number 1, right? But then the weight here is equal to mass number 1 multiplied by G. Good. However, here we have the steel surface here pushing through the aluminum here. So we have the normal force here goes up. So I will name this as N1. Good. And then here we also have the tension of the rope, which is going there, pulling this M1 to the right. So here we have our tension of the rope. So I will have T here. But then if it moves there, we have a friction force moving to the other direction. So I will have this one here, the friction force. So I'll have FF. Okay, let's name this as friction number 1. However, we need to find out what is FF1, right? So we'll have force of the friction number 1. And because they are moving, because we have an acceleration, we need to use the mu k, right? Mu k multiplied by the normal force. So I will have N1. However, we need to find out what is N1 first. So here, let's use the Newton's second law to get this N1 here. So remember that we have sigma F is equal to the mass times acceleration. However, we have the vertical direction here, Fy, and acceleration also on the y direction. But then the movements goes to the right. We have no vertical movements, right? So we will have on the right hand side here that will equal to 0. Okay, and that means that I will have N1, which is the force in the positive direction, and then minus W1 here on the negative direction. And all of that will equal to 0. So we will have the normal force here is equal to the weight of mass 1 here. So I will have W1. But the W1 is M1 times G. So I will have the normal force of the block 1 here is M1 times G. And all we need to do is plug in the numerical values. What is it? We will have M1 here is 2 kilograms. So I will have 2 multiplied by 9.8. And that will be 19.6 Newton. So I have N1 here is 19.6, and the unit here will be in Newton. Good. And that is the forces, that is the normal force. Okay, so now let's do on the horizontal direction here. So we will have sigma Fx, and that will equal to the mass times acceleration here. Let's name this as Ax. Okay, and the movement is going there with an acceleration of Ax, right? And this is not 0 because they are moving in that direction. Okay, so on the positive direction, I will have T. And then on the negative direction, I will have FF1. So I'll have minus FF1. And that will equal to the mass of the block, which is 2. And I multiply this by AX. Good. Now what is FF1? So we'll have T minus mu K times N1. And that will equal to 2AX. But then what is the mu K? We have an aluminum on steel, right? So that is this one here, aluminum on steel. And because we need the mu K, we have this one here, 0.47. So let's plug in the number. So I'll have T minus 0.47. And then multiplied by N1, we will have 19.6. And that will equal to 2AX. And now let's put all the variables to the left hand side. So we'll have T minus 2AX. And that will equal to this one here, 0.47 multiplied by 19.6. So we'll have 0.47 multiplied by 19.6. Okay, and I will have 9.21. 9.21. And I think nothing that we can do further from here for the aluminum one. So let's save this as equation number 1. And then now let's move on to the copper one. And we need also to draw all the forces, right? Okay, let's do that. Okay, now let's do the copper here. And let's draw all the forces that works on this copper here. Obviously, we have its weight, right? So let's name this as W2. However, here we have some angles to the coordinates axis. So we need to project this into two components. And theta is here. So here, on the y-axis, I will have W2 cosine of theta. But here I will have W2 sine of theta, right? That is the projection of this one goes to the x-axis like this. But then the steel on copper also giving normal force there. So I will have to name this as N2. And then because the direction of the movements is here, we have the friction on the opposite sides. So we will have this one as force of friction here. But then we also have the tension of the rope, right? So we'll have this one here is T. Good. Now we start with this y direction to find out N2. So we will have sigma F on the y direction here is equal to the mass times acceleration. However, there is no movement on the y direction, so I will have this equal to 0. Good. And then what can we do from here? I will have N2 here as the positive forces, and then minus W2 cosine of theta as the negative force. You see in the axis here, and that is equal to 0. Okay, so we'll have the normal force number 2 of this copper. So I will have W2, which is M2 times G, and then cosine of theta. Let's plug the numerical values. So I will have N2, the mass number 2 is 6 times G, which is 9.8, and then cosine of theta. So I will have cosine of 30 degrees. Good. And now we will have 6 times 9.8, and then cosine of 30 degrees. And I will have 50.92. So I will have N2 is equal to 50.92 Newton. And this will be very useful to find out this friction force number 2. Right? Okay, so now let's do on the x direction, right? So I have sigma F on the x direction. So I'll have the mass times acceleration on the x direction. On the positive side, we will have this one, W2 sine of theta. And then we will have minus this one here, FF2. Okay. And then also the tension of the rope. So I'll have minus T, and that will equal to the mass times acceleration in the x direction. Good. Now let's do some plugging here. W2 is M2G, and then we will have sine of theta. And the force of the friction here is mu K times normal force. So I'll have N2. And then I will have minus T here. And then the mass here is 6 kilograms. So I'll have 6 AX. Okay, I think we can just plug the numbers here. Mass number 2 is 6 kilogram. And then G is 9.8. And then sine of theta. So I'll have sine of 30 degrees. And then mu K. This is between steel and copper. Copper on steel here, which is this one. And I will have 0.36. Good. So I will have 0.36. And then N2 here is 50.92. So I'll have 50.92. And then, okay, I will have minus T here. Let's continue here. And that will equal to 6AX. Okay, and this part here is just numerical values, right? And we can calculate that using calculator. So I will have 9 times 9.8, 6 times 9.8, and then sine of 30, and then minus 0.36 multiplied by 50.92. So I will have 11.07. Okay, so I will have 11.07 here. And then we will have minus T is equal to 6AX. Good. And now we can just use rearrangement here. So I will have T and then plus 6AX. And then we will have 11.07. Okay, we have equation number 2. So now we have two equations with two variables, right? So we should be able to solve it. Okay, let's solve that. But let's clean up our slide first. So now we have two equations with two variables. All that we need to do is solve it. And the fastest way to solve it is by using calculator. Okay, let's do that. So let's set this up as equation solver, this one and number 5. Okay, and two variables is number 1. And then we will have to plug in the coefficient. So I'll have 1, and then minus 2, and then 9.21. Good. And then I will have 1, and then 6, and then 11.07. Good. And I will have this as our tension here, which is the first variable, T, and that will be 9.78. Okay, so I'll have our T here is equal to 9.68. Yeah, 68 here, and the unit here is in Newton, and the acceleration here, AX. What is AX? That is the Y value here, and that will be 0.23. So I have 0.23 meter per square seconds. And this is the answer for question A. And this one is the answer for question B. And let's highlight that as our final answer. Okay, I think that's all for this problem. Hopefully I did not make any mistakes during my calculation. Thank you for watching. See you in the next video. Bye-bye.